The topic and technique of masking belongs rather to style than speed. We have done a little bit of this already under the other term, logical indexing. So here again as an example, we have a function which for a given set of arguments x can take values either following the given formula if absolute value of x is less equal than a half, or otherwise it's 0 if absolute value of x is greater or equal half. So that means that our values of this function are conditional on the x values. If we were to do it in a loop, we would consider, of course, defining our x values. Then we pre-allocate memory for the vector for function values. And then we write a loop which visits every single element of x and acts on it, or acts on the calculation of the function value based on the condition. So the condition was that if x, absolute value of x, is less equal 1/2, then we have the formula, and otherwise there are zeros. Absolute value in Matlab comes with function abs. So you see within my abs function here in the brackets I have always that particular jth element of x. One at a time I check, is it less equal half? If it is, I create the respective jth element of my f vector and use the formula which was given. You could think why there is no else. I could have had else and say else fj equals 0. But that's why memory pre-allocation, especially in a smart way, helps you avoid this extra step, because I have created my f vector to already in such a way that it already contains zeros, which means that in case this value doesn't come up, the 0 is there already, so I don't need else at all in this case. So this code runs in about this much time, again on the same type of computer. And if we would like to do masking on it, so it means that after the definition and memory pre-allocation, we create so-called mask, or what I used to call in the previous weeks logical index. So that means that we take our entire vector x, its absolute value, and compare it with our condition. So we ask whether absolute value of vector x is less, should it be less equal 0.5. Now this we already know that for given values of x, our mask, where x can have anything, mask will have zeros and ones depending on whether this condition is true or false, or this statement is true or false for that particular value of x. And then when we put those true-false values into our f, we point that within f vector to the places which have true value here, put in this calculation. And now notice we cannot put this calculation just saying cosine 2 times pi times x, because this result would be bigger, most likely, than the place we try to point the things into. So only for the x's, again, only for x's satisfying our masking, we do this calculation and we put the results into respective places in our f vector. Now this code runs just a little bit faster, and it might be that for some cases it may even run just slightly longer. So in this case, using a loop or masking is almost equivalent. However, this is the style question, because a code where you use masking or logical indexing just looks better. And then, for instance, if you want to do something with the elements that are not under the mask, you just use not mask. So for instance, you would say that f of not mask equals something. Again, in our case, it should be 0, which is there already, so we don't have to do it. But if you wanted other values than 0, then you can set that value in there.